Greetings, everyone. Over the past week, I built a complete working Flutter application. This is a flashcard application with a Smart Spaced Repetition Algorithm, or SM2. In this video, I'll show you this application, break down the key features, and explain how I implemented the algorithm in the app. The full source code of the application is available in the video description. Let's start with our application's tech stack, and then we'll look at how it works. First, as you've already understood, the application is written using the Flutter framework with Dart. For architecture, I chose Clean Architecture. Next, State Manager. I chose BLoC because it's more familiar to me and is a more professional solution for projects. With proper implementation, it greatly simplifies code writing and future optimization. Next, there was a choice of how to store and manipulate data. Initially, I thought about writing a separate backend for this, but I decided it would be better to store everything locally so users wouldn't need internet for repetition. Therefore, I chose SQLite database. I also used dependency injection in the application, and for this, I used the getIt package. Finally, for navigation in the application, I used GoRouter. Now, let's look at how our application works, and then we'll move on to the code. Initially, when we launch, we land on the main screen of the application. At the top, we see the application name with a theme toggle button. Let's try switching our theme. As we can see, this feature works perfectly. A bit later, I'll explain how I implemented this using BLoC. At the bottom, we have a plus button for creating a deck. When we click on it, a dialog opens where we enter information about the deck. Let's create our first deck. When we click Create, it immediately appears in the list. Here, each deck has 3 dots that, when clicked, open a dialog where we can edit or delete the deck. Let's see how this works. For example, we want to edit our deck. We'll just change the name. As you can see, all changes are immediately applied, and everything is saved to our local database. Now, let's try deleting this deck. Here, we see a warning dialog so the user doesn't accidentally delete the deck. Let's create the deck again. After creation, we can click on it and go to its screen. Here we see the deck name and brief statistics about it. We don't have any cards yet, so let's create one. Here we have a similar dialog, but here we need to specify the front and back sides of the card. Upon creation, we immediately see it displayed, and the statistics at the top also changed. Also, if you noticed, it has a Ready for Review label, and along with this, we now have a button at the bottom to start review. Let me briefly explain how this logic works. You'll understand in more detail later. When creating cards, the user can review them. For each card, they'll have several answer options depending on how well they answered it. Depending on the answer, the date for the next repetition of this card will be formed. The algorithm will calculate, and those cards that the user consistently answers well will be offered less and less frequently. Conversely, cards where the user makes mistakes will be shown more and more often. Here, by the way, we also have 3 dots for editing and deleting cards. Let's add another card. Now, let's try to start review. As you can see, we land on a screen where the current card is displayed along with answer buttons. We can click on it to find out the answer and assess how well we know it. The card flips with a beautiful animation when clicked. We also have a button to skip the card. Let's try clicking Easy for the first card. As we can see, the application immediately switched to the second card. Here, we can also flip it. For this one, let's choose Again, as if we don't know the answer. After we've finished all the cards and have no more cards available for repetition today, we see this screen. Here, we can return to the screen with the card list. Now, pay attention to the cards. The card, where we chose Easy, got a next review for the next day, and the card we marked as Again is still ready for review. Accordingly, we can click Review Again, where we'll have only one card. Let's mark Good here. Now, this card also shows Next Review for the next day. You might wonder why they have the same date if we chose Easy for one and Good for the other. But the thing is, this is how this algorithm works. The differences between these answers are felt over a longer period of time. For example, if we continue clicking Good on one card and Easy on another, one will increase by roughly another day, and the other by a week, and so on. Now, let's go back to the main screen. As we can see, we now have some data in the chart. This chart, by the way, is implemented using the FL chart package. Here we see that today we reviewed 3 cards, and our current streak value also increased. You might wonder why we have 3 cards here when we only have 2 cards in the deck. But remember how we went through one of the cards twice because we chose Again the first time? This application counts all reviews for cards for statistics. And also, for today's streak to count and increase, we need to review at least 3 cards per day. This is needed to motivate users to go through cards. Let's see how this looks in dark theme. Notice that we also changed the deck information on this screen, and we see the next review date here. Let's create another deck. Then, let's go into it and create several cards in it. I'll use abbreviations for the front and back parts. Let's start reviewing them. We'll skip the first card. For 2, we'll say Good. And for the last one, Easy. As we can see, the card we skipped is still available for review, and the others have their next repetition in one day. Let's go through our card that we skipped. This way, its next review date also changed. And, by the way, if we try to click Review when we have no more cards available for repetition, we'll land on the same screen. Next, at the top, we have an interesting button that allows us to completely reset all progress for the deck. Here, there's also a dialog so the user doesn't do this accidentally. After resetting progress, we also reset them in the algorithm, so they're now all available for review again. Let's exit and pay attention to our statistics. Here, we now have 7 viewed cards. Let's also try sorting our decks. There's sorting, for example, by number of cards, and we can also choose descending or ascending order. Let me now change the date to the next day on the emulator for testing. Here's what we see. Now, our progress is shown as yesterday in the chart, and all decks are available for review. Let's start with the deck where we have 4 cards. As you remember, we reset progress here. Let's go through it. Since we reset progress after completion, the date for each card again shifted only by 1 day, despite choosing different options. This is normal, as this is considered the first repetition of the card. Next, let's go to the other deck. Here, we'll also choose Answers. Here, our cards have already shifted by 6 days. Let's go back to the main page. As we can see, our streak increased and data appeared in the chart. If you study with it every day, it will be very convenient to track how many cards were viewed on which day. Let's change the time forward by 1 day again. Thus, one of the decks is still unavailable because it was postponed for 6 days. The second is already available. Let's go into it and try to go through the cards. Here, we'll also specify different answers for cards, and for the last one, we'll specify again. Thus, for 3 cards, the interval again shifted by 6 days. In our algorithm, the first 2 repetitions, regardless of whether it's easy or good, increase by the same number of days, and then they're calculated differently. Let's go through our last card for which we chose again. Notice that our streak increased again. Let's now change the date by 6 days forward so we can work with the cards. As we can see, our streak reset, and we also don't see data in the chart because they were left behind. Let's try working with the cards. Notice that we now have different repetition times. Now, it differs by only 1 day, but the more we work with it, the more sensitive the algorithm will be. Also, notice that these cards are considered learned. They're considered learned because they were chosen easy or good 3 times in a row. By the way, notice that our streak didn't increase even though we went through 2 cards. The thing is, as I said before, streak is only counted with 3 cards per day. Now, let's go to the next deck. Notice that here we also chose different options for 1 card, so it has a different next review date. Now, our streak has been updated. Well, let's now move on to our code and break down the key features. Let's start with main.dart. Here I have widgets Flutter binding ensure initialized as the first line. This is needed for correct operation of dependency injection. Here, the next line is exactly that, but let's look at it a bit later. Next, I have 2 commented lines. Let's try uncommenting them and importing them. These are 2 methods for filling the database with mock data for testing the application. It creates 50 decks with different cards. After that, we launch the application. Now, let's look at the application structure. I use clean architecture, and I have 2 main folders, core and features. I currently have 3 features, and each feature is divided into clean architecture layers: data, domain, and presentation. Each of them is also divided into their own folders. I actually have a separate lesson on the channel about clean architecture where everything is explained in detail. Let's start with the core folder. The first folder here is DB for our local database. Here we have a mock folder where there's 1 file with those methods I showed you for populating the database. Next, we have a database helper file. We use SQLite database, and we need a file that will create and return this database. Here we have constants with table names, version, and file name. Next, we have a method for database initialization. For this, SQL language is used to initialize tables for each of our models. I'll give you a small tip. If you don't know this language, you can simply generate this code using artificial intelligence by uploading your Dart models to it. Next, we have a folder and file for dependency injection. Here, we create and inject practically all dependencies used in our application. By dependencies, I mean, for example, a repository that our use case depends on to perform some operations. A lesson about dependency injection also recently came out on my channel. Let's go to the beginning of the file. Here, I first get a getIt instance, and in the method, start injecting dependencies from the top layer. The top layer is database helper since it has no dependencies itself. Next, we have data sources that depend on this database helper. Then come repositories. Notice that we specify the abstract class in generics and inject its implementation. This way, when the application requests a dependency of the abstract repository, we'll get our implementation. Next, we inject our use cases, and finally blocks. Next, we have an entity folder with only 2 files. Our application uses pagination for some queries, so I extracted this into separate entities. The first entity stores information about offset and limit for the query. Notice that almost all our entities inherit from equatable. This automates the implementation of some methods, for example, comparison. For this, we pass all our parameters. The second entity is needed for returning results. Besides a list of elements, it also returns the total count, current offset, and limit. Notice there's also a has more field here, but we don't pass it. It's calculated automatically in the constructor. Next, we have several files for working with results, such as failure and either. Either allows us to return two possible values from a method, left or right. This allows us to easily handle errors. For example, if we see that the response is left, we understand it's an error, and vice versa. Next, we have navigation implementation in our application through GoRouter. Everything is simple here. I declared all routes in a list. I also use constant values for specifying paths, and there are methods for building paths if you need to pass IDs. The next important element is theming in the application. I usually start this with colors. I declare a class with all the colors I customize. Then, I create two static fields of the same type for light and dark themes. Additionally, I have an enum that has only these two values, and also an appTheme class that has one method. It takes my colors and returns a Flutter understandable theme based on them. Notice that here we also have domain, data, and BLoC layers. Let's start with domain. Here we have a repository for working with themes with two methods, for getting the theme and for changing it. This is an abstract class, so we need to implement it somewhere. But now, let's look at use cases. They use our repository and have only one method. Use cases are needed only for executing one operation and have corresponding names. Here, we return simply the result of our repository method. But where do we implement it? In the data layer. Here, we pass our data source for themes and also simply return the result from its methods in the methods. As for the data source itself, here we simply save or get data from shared preferences. Here, we don't use SQLite because we need to work with only one value. Now to more interesting stuff, our BLoC. It takes our use cases as dependencies and works with them. Here, we register our events and handle them as usual. Look at how my state is structured. Usually, I always have only one state. First, I declare a status enum for it, and then the other fields. I make its constructor private and provide creation through a factory method. I make all changes to state through the copy with method. If all this seems complex to you, I recommend watching my Flutter course playlist and other videos where I write complete applications. Now, let's see how this BLoC is used. We use BLoC provider above material app in our method. Above material app, so it's global. Here we use the service locator from getIt to get our dependency as a BLoC and immediately add an event to it for loading the theme. Next, our material app is wrapped in BLoC Builder. This way, every time the state changes, we'll redraw it and see the theme change. Here, we simply use our state to pass the theme to the application. Next, we have two remaining files in the core folder. Everything is simple here. These are just customized text field and elevated button to avoid code duplication. Now, let's move to features. For example, Home. Here, as I already said, it's divided into 3 layers. Let's start with domain and the entity folder. Here we have an entity for deck. Notice it also inherits from Equatable. Everything else is simple. It has its fields and also a copy with method. After that comes our abstract repository. Here we have different methods for working with DEX. Notice how complex the return type looks. Here we have future since the operation is asynchronous. After that, either, into which we pass failure as the left value and a list of our DEX as the right value. This means we'll get either a left value with an error or a right value with our list. But, as I said earlier, we use pagination, and here's how it looks. Here, we use that same entity instead of a list, which already has a list in its fields. This method also takes our entity to specify offset and limit. Now, let's look at our use cases. Here, there's nothing complex in many use cases either, just calling our method from the repository that's passed as a dependency. Let's move to the data layer and its repository folder. Here's the implementation of our abstract repository using the data source dependency. Notice how this happens. We use try-catch. If there are no errors, we return a right object. If there are errors, we return left. This is how either works, and at this layer, it's most often already known whether we'll get a right or left value. We also transform our models into entities. I'll show you what the model looks like soon. And here's the model itself. It inherits from our entity, and the difference is that an entity by its nature shouldn't work with JSON and so on. But a model, since it's in the data layer, has corresponding methods. Next, let's move to the data source. Here, like with repositories, there's a separation into abstraction and implementation. Here, we're more interested in the implementation. Here, we use our database helper and execute SQL queries with it. We build the query depending on parameters and return the result. Now, let's look at how the presentation layer works, namely BLoC. Here we pass our use cases as dependencies. Next, in the constructor, we register our events. Let's look at an example event to get DEX. First come checks, for example, if we're on the last page or loading is happening. In such cases, we abort the method. If we want to refresh, we change our state using copyWith. Next, we simply use the use case, and depending on its result, we change our state also using emit and copyWith. Now, probably the most interesting part. Let's look at how I implemented the SM2 algorithm in the application. Let's start with the use case needed to update a card by quality. It takes as many as 3 repositories. Its method takes a card ID and quality. Quality is an enum with our values. Each value also has an integer value. This is needed to simplify calculations. First, in our use case, we get our card by its ID. In case of a left value, we simply return it further. In case of right, we go further. The next step is using the SM2 service to update the card. The SM2 service is our repository with one method. Let's look at its implementation. It takes our flashcard entity. Let's look at its fields. We're interested in the repetition field, which displays the number of correct repetitions in a row. Next, easiness factor. This is a value from 1.3 to 2.5 that's used in interval calculation. After that, interval, which reflects the number of days until the next date. And finally, the next review date itself. We start the method by creating 3 variables to which we initially assign current values from the card. Next, we need to calculate the easiness factor. For this, there's this formula. To put it briefly, it depends on the quality we chose: easy, good, or again. Next, we limit this variable so it's at least 1.3 but not more than 2.5. Then we check if quality is less than 3, meaning again was chosen. We reset the repetition count and interval. In other cases, we increase the number of correct repetitions in a row. Next, we check if it's the first or second repetition, then we specify the interval manually. Remember how it was in our application for the first 2 repetitions? If it's the third or more repetition, we simply multiply the current interval by the easiness factor and round it. After that, I again limit the interval if it turned out to be more than 1 year. Next, I simply calculate the next review date and update the flashcard. Let's return to our use case. After updating the flashcard in our SM2 algorithm, I save it locally. Here also, if the result is left, I simply return it. If it's right, I update the daily statistics. Remember the chart and current streak in the application? It's calculated using this. Here's simple logic. Here's what the model we store looks like. It has a statistics date and also the number of cards, correct answers, and errors. Now, let's look at the method itself. First, I get today's date. Next, I try to get statistics for today's date if it exists. In case of a left value, I understand that there are no statistics for today, so I create new ones. I also do the same thing if the value is right, but it's null. But if we were able to get statistics for today, it means we already worked with cards today and we just need to update the statistics, not reset them. Here's also simple logic. This is how this algorithm looks. You can find the full source code in the description under the video. If you liked the video and application, please like and subscribe to the channel. If you have any questions, please ask in the comments and I'll try to answer them. Thank you for watching. See you in the next video.